What I want to talk about today is basically finding, or I guess solving limits just through substitution mainly. So the first example I want to do is, let's say you had the limit as x approaches to 0 of 1 over x minus 2 squared. So pause the video and see if you can figure this out. Basically with this one, you're basically just going to substitute in as if x equals to 0. Now we talked about it in the last video where, x is approaching 0, right? X is approaching. It is not equaling 0. It's getting very, 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 very infinitely smaller and closer towards 0. But we can just still substitute it in because it basically becomes 0. So this would just be 1 over 0 minus 2 squared. 1 over negative 2 bracket squared, which just gives you 1/4. Pretty straightforward. Another example I want to do is for a piecewise function. So if I write the piecewise function of f of x equals to x squared when 0x, so when x is greater than 0 and it's less than 2, and then 4x when x is greater than or equal to 2. So let's say I asked find the limit of x approaches to 2 from the right of this function. So you can pause the video and try this one out. So the way you would do this as well, you have to look at what parts of the piecewise function sort of fit with this description, this idea of coming plus 2 from the right. So if I draw a little number line here and I have my 2, this would be the, the positive land, the negative land, right? So this would be like, 2.01, and this would be 1.99. And so it's asking, well, find the limit as you're coming from the right. So it has to be greater than 2. So we're going to use this guy because this thing is greater than or equal to 2, whereas x squared is less than 2. So we'd use this. So this would be 4. And then in the brackets we put our 2. This would give us 8. Now what if I said, let's find the limit of x approaches 2 from the left? What would that be? So if we draw the number line again, if that's my 2 here, we're asking from the left, so it has to be from here. So what's less than 2? Well, it's this guy over here, x squared. So we're going to use x squared, so that's just going to be 2 bracket that, and that just gives us 4. Now what if I asked, so I'll just square the final answers here. Now what if I asked for the general limit? Like, let's see if there was an actual limit to this function. If I said as x approaches to 2 of f of x, what does that equal? Well, we talked about in the last video where if the limit of the same value from the left and the right don't equal each other, then there's no limit. So let me write that. The limit of x approaching to a from the positive side, from the right side, does not equal the limit from the left side. There is no limit. There is no actual limit of the thing. And in this case, well, we can see there actually is no limit because from the right, we get a final answer of 8, and from the left, we get a final answer of 4. So therefore, there is no limit. No limit. So we have to keep that in mind whenever you're asked to find a general limit of, like, a piecewise function or maybe, some sort of reciprocal function. Another example I want to try is the limit of x approaching negative 2 of x cubed plus 8 over x squared minus x minus 6. So the way we do this is, well, we see an x cubed plus 8 over here, And we see this guy over here, x squared minus. So what we can do with this is, well, this actually looks like a sum of cubes, right? This looks like a cubed plus b cubed, which is just a plus b, a squared minus ab plus b squared, right? And this guy we can just factor, straight up factor it. So if we do that, well, we get the limit of x approaches -2, and first we're going to factor. So a plus b, so that would be x plus 2, because if you cube, you get 2, so it'd be x plus 2, and then you get x squared minus, now that's just 2x, b squared, so that's just 4, so because 2 squared, and that's what you have. And then the bottom, well, this is just a simple quadratic. This is x plus 2, x minus 3. And if you want to verify that, just quickly expand it. You get x squared, you get plus 2x minus 3x minus 6. This gives you x squared minus x minus 6. So it works out. Always good to double check your work. Now, if we look here, as x approaches -2, if we plugged in a -2, this thing would become 0. But the top, I don't know if you see this, but the top has x plus 2 and the bottom has x plus 2. So we actually can just cancel these out. And then we just get x squared minus 2x plus 4 over x minus 3. And now we can just substitute. So -2 squared minus 2, -2 plus 4, -2 minus 3. Well, 2 squared is 4. 2 times -2 times 2, that's just 4, plus 4 for -5. 4 plus 4 is 8, plus another 4 is 12. And that's what you get. The final example I want to do is the limit x approaching 4 of x plus 5 root of this entire thing minus 3. Yikes, that looks terrible. Hold up. X plus 5 root minus 3 over x minus 4. Now we know we can't just plug in the 4, because then this thing would be, over 0, and then that'd be undefined, so we wouldn't be solving. What we want to do is we're sort of working backwards. So and what I mean is, if you recall, let's say when you get something, and when you have a radical in the denominator, you rationalize the denominator, right? You just time this by the conjugate, okay, root x over x, right? It's the same thing. In this case, what's going to happen here is we're going to work backwards. We're going to make the denominator have a radical. I'll show you how we're going to do that so that we can solve this. So I'm going to write root x plus 5 minus 3 multiplied by x plus 5 root plus 3 over x minus 4 x plus 5 plus 3. So if you see, this and this would just cancel out. So we haven't really changed one. We're just doing some algebraic manipulation just to try to solve this limit. So we aren't doing any, wrong moves here, per se. And now we can just expand the numerator. So this is like a difference of squares. This is a, b. So that would give you a squared minus b squared, right? Because there's a minus here, there's a plus here. So that's all we're doing. So that would just be x plus 5 minus 9 over x minus 4 x plus 5 root 3. And then the limit of x approaches 4. X plus 5 minus 9, that's just x minus 4. X minus 4 again. X plus 5 root 3. Sorry, not root 3. Root x plus 5 plus 3. And we can see something here. Well, we can sort of just cancel this x minus 4 out. Because it's in the numerator, it's also in the denominator. So we just get limit as x approaches to 4, 1 over x plus 5 under the radical plus 3. We're going to bring in the 4. That's 1. 4 plus 5 is 9. And then when you square root of 9, you get 3. And you get 1 over 6. And that's it. That's how you sort of solve something like this. You sort of work backwards, because generally when you have the radical in the denominator, you try to get rid of it. This you're sort of working backwards, just some algebraic manipulation. And yeah, that's pretty much it.